Okay, we're going to look at section 8.3. In this section, there are several problems on confidence intervals. Some of these problems you will work by hand, and others you will work using StatCrunch, or if you want to use Excel. But on the first question, since we do not have a table, we are going to use StatCrunch. So you go to StatCrunch. If they don't provide you the table, you can use StatCrunch if you know everything needed to fill the information in. Go to T-Stats, one sample with summary, and then you fill in everything. We can see in our problem the sample mean is 24, standard deviation is 5.5, and sample size was 21, and we want the confidence interval of 90%. So let's put in, click on confidence interval and click on 90% and click compute, and it's going to give you the lower and the upper, and you need to round to the second decimal place, so 21.93 and 26.07, and we always assume that the population will follow a normal distribution. For question number 2, you have your critical t-score tables. So what you need to do is you're going to calculate this by hand. So we know that we know the mean, standard deviation, n equals 21. So what you have to do is, okay, so we will calculate this one by hand. So first of all, what we need to do for problem number 2 is look up the degrees of freedom, which is, let's do that first. The degrees of freedom would be 21 minus 1, which would be 20, and it's an 80% confidence interval. So we're going to do 80%, which is right here in the second column, and go down to 20. And we get 1.325. So we will calculate our confidence interval by saying we have to calculate one more thing, and that is margin of error here, standard error. We do S divided by the square root of n, and we know S is 8.9, and we know n is the square root of 21, and if you do that, you round to 4 decimal places, so you get 1.9421. And then remember, our other number in our table, our t value, is 1.325. So what we have to do is we have to take the 35, the mean, and we have to add 1.325 times 1.9421, and we will get the upper limit, which is 37.57. Then if we take the mean and do 35 minus 1.325 times 1.9421, we will get the lower limit, which is 32.43. And we have to assume the population follows the normal distribution. Okay, moving on to the next question. Give it just a second. See if I can get this to work. Then looking at question number 3, this is the one where you will go into StatCrunch, back into StatCrunch. Now you can use the table, but they want you to use technology, and you will go to T-Stats, one sample with summary, and you will put in your sample mean, and our sample mean is 68, and our sample standard deviation is 12.7, and our sample size for A is 22, and we want a confidence interval of 80%, and you hit compute, and you see your lower limit is 64.42, and your upper limit is 71.58. And you do the same thing for each of the next one. If you want to go to options and edit, you can go back to where you entered it, and then you can enter the next one. This time the sample size is 39, and you hit compute, and you can see that our lower limit is 65.35 and our upper limit is 70.65, which is what we have there, and here's where you find it in StatCrunch. So that is all you do for this problem. Moving on to question number 4, here you're going to calculate these by hand, and I believe I worked question problem number 4 in another video, so we will skip it. Problem number 5, it wants you to determine just the margin of error. We don't know what the mean is, so what we want to do here is we want to calculate, we need to find the t-value, and then we need to find the standard error and multiply those together. So for A, we know that the confidence interval is 80%, and we know that the degrees of freedom is 16 because it's n minus 1. So if you do that, if you look at that in your t-table, and how are you going to do your t-table if it doesn't give you one on this problem? Well, let me see if I can show you how to do that. If you go to your textbook, into your appendix, go to your table of contents, into your appendix, and click on your t-distribution, and look at your degrees of freedom, and we want 80%. Okay, go to your bookshelf and do it. And you want degrees of freedom of 80%, and we want 16, so we're going to have to go back to the previous page. Hopefully it will let us in here. Degrees of freedom of 16 and 80%, we get 1.337. Let me make sure that that is right. Yes, 1.337. Sorry, I had to find what problem I was on. So what we're going to do is we're going to do 1.337. We're working A, and then we need to do the standard error here, which is the standard deviation divided by the square root of n, which is 17. So if you do 15.7 divided by the square root of 17, you get 3.8078, round to 4 decimal places, times 1.337. If you multiply those together, you get 5.09. Okay, now for B, we're going to look up 90% confidence interval in our table. 90% confidence interval with the degrees of freedom of 16. So you would go to your chart and go to degrees of freedom of 16 and 90% confidence interval. Here's 0.90 right here. Degrees of freedom of 16. You get 1.746. So we're going to go back and we're going to do 1.746 times that other number that we just calculated. We don't have to calculate it again, because n is not changing and the standard deviation is not changing, so this number doesn't change. So when you multiply those together, you get 6.65. For the next one, you would do the same thing. You would go to your degrees of freedom of 16, but the confidence interval would be 0.99. So what we're going to do is we're going to erase this number here, and our t-value, if we looked it up in our chart, would be 2.921. All you do is look up 99% confidence interval and degrees of freedom of n minus 1, which is 16. So when you multiply those together, you get 11.12. Okay, moving on to question number 6. Same thing. You're doing margin of error. Work it just like you did number 5. Number 7. This is one where you can put it all into stat crunch, just like we did earlier, where you do your n value. It says the average beer over 22 randomly selected, so n is 22, and then the standard deviation would be 81,506. Not the standard deviation, the mean. And then the standard deviation would be 4,525 bottles. And then we would do for the confidence interval 0.95, and you put all that in and get your upper and lower limit. Make sure you round. The only assumption we need is the population follows the normal distribution. Question number 8. N would be 24. The mean is 5,184. The sample standard deviation is 1,793. And the confidence interval is in 0.80. So you would go in, let's see if we still have it open. We don't. Okay. You would go into StatCrunch just like you've been doing. And you would go to Stat, T-Stats, one sample with summary, and you would put in mean, standard deviation, sample size, and change your confidence interval and hit compute. And it always, we assume the population follows a normal distribution. For question number 9, same thing. You're going to put all of this information into StatCrunch. And since the 50,000 here falls within the confidence interval, 50,000 is in between these two numbers, we can be said with 99% confidence, because it's 99% confidence, that the sample validates the airline company's claim. If it did not contain the 50,000, we could be said that the sample does not validate the airplane's claim. Okay, and then what assumptions can we be made? We can assume it follows a normal distribution. Question number 10, what you're going to do is you're going to open this in StatCrunch. Same thing you've been doing, but we don't have the mean. So what we're going to do is we're going to do T-Stats, one sample with data, okay, and choose variable 1. And the confidence interval is 0.99. And what I'm going to do is say stored in the data table and hit compute. And then you're going to see your lower and upper limit here. See how 2.46 and 6.72. What assumptions will be made? That it follows a normal distribution. Question 11, work it the same way you worked number 10. And question 12, you work it the same way as you did number 10 and number 11.